Welcome everyone this evening to our next webinar talking about VEX Code VR and our latest, biggest update to it. Thank you very much for joining us. We're very excited to have you here. We're really excited for this next release of VEX Code VR and share it with you and talk about all of the new great features that we have with it. Also some other things that we've released over the course of the last month. We're excited to share that with you also. So without any further ado, let's just go ahead and get started with it. As I mentioned, my name is Jason McKenna. I'm the Director of Educational Strategy here at VEX Robotics. Basically what that means is I get to oversee all of our educational development for all of our platforms. Of course, VEX Code VR, which we're going to be talking about a lot this evening, but also VEXiQ V5 and our two newest platforms, VEX Go and VEX123. So I get to see all of different educational development, our STEM labs, our certification program, and also our knowledge base designed to support all of our teachers and users. I'm a former classroom teacher myself. I taught for 20 years right outside of Pittsburgh here in Western Pennsylvania. My last few years teaching, that's when I was introduced to educational robotics. I got to share that with my classroom and community, and now at VEX, luckily I get to share that with the entire world. If this is the first time that you're joining our webinar, welcome. If you've joined our webinars previously, or if you joined the webinar a couple weeks ago with Grant when he talked about our new VEX games, you should be familiar with our format. I'm going to talk for about 45 minutes, around that. I might go a little bit long or a little bit short, and we'll have 15 minutes at the end dedicated to Q&A. But you don't have to wait until the end to actually ask your questions. You can use the chat function in YouTube to ask your questions, or you can use any of our VEX social media channels to go in and ask questions. I have some folks helping me out. I'll be answering questions during the webinar, and also sending some to me at the end where I can answer those questions for everyone at that time. This webinar, like all of our webinars, are being recorded. So if you have to leave early this evening, or if you know someone that would like to watch it but couldn't join us live, you can always point them to our YouTube channel where you will be able to find this recording, but also all the rest of them. A few minutes ago, I mentioned the webinar, our last one with Grant Cox, who talked about the latest VEXiQ and VEX V5 games. That was a fantastic webinar. If you didn't get a chance to watch that, you can go to our YouTube channel. You'll be able to see it there. So what are we going to talk about today? What are we going to know today? Well, if you've been following us on social media, you know we've been talking a lot about Python, and that's really the big update to the VEX Code VR. You'll now able to program your VEX Code VR robot in Python. So I'm going to show you a lot of that, walk through a lot of that with you here this evening, and talk about that a lot with you. In addition to that, we also are going to talk about how we're making the transition from block to text-based program a lot easier. This is feedback that we've heard consistently from teachers and schools and even students going back to when we first released VEX Code last summer. People are always asking about, how do I transition my students from blocks? I love introducing to them programming with blocks, but how do I transition them to text-based programming? We developed some things in VEX Code VR, which I'm going to show you here in a moment, to help make that transition easier. The advantages of using VEX Code VR to teach computer science, obviously with VEX Code VR now supporting Python, we're going to talk about that, but also just some of the features of VEX Code VR. And also, as we've been releasing these features of VEX Code VR, we've gotten a lot of questions about, what's in store, what's coming down the pipe, what's your software roadmap. So I'm going to shed some light upon that and talk about that a little bit with you this evening here also. We've gotten a lot of great feedback about VEX Code VR. Of course, all of us, whether you're in education or not, our world has been turned upside down because of the COVID-19 pandemic. Most teachers who at this time would be wrapping up their school year, saying goodbye to their students, wrapping up their classrooms, now they're doing all that from their living rooms. We developed VEX Code VR to try to help support teachers in this time of crisis so that their students can still stay connected to VEX Robotics and also stay connected to computer science. From idea to execution, it was 3 very short weeks. We were able to get this out here. We had a webinar a couple months ago in which we unveiled this. And the feedback that we've gotten from teachers has really been fantastic to see. This is a great example that you see on your screen right now. I get emails from teachers. I get teachers pinging me on Twitter, sending me direct messages, messages going to VEX directly, our feedback channel on our app. This is a lot of the things that we hear, and this is really gratifying for us because our software development team, our education team, and our web team, all of us have worked really, really hard over the course of the last couple months in order to get VEX Code VR to you in your hands so that you and your students are able to enjoy it and use it. So it's really gratifying to continue to see these types of messages come from our customers. Some VEX Code VR statistics. The last webinar that I did, I shared statistics like this also, and of course they've been updated since then. Over 160,000 unique VEX Code VR users, over 500,000 VEX Code VR coding sessions, and over 7 million playground projects ran since the unveil of VEX Code VR a few short weeks ago. Massively successful. One of the things that we talk about, and I'll talk about this a little bit later, that's really important about VEX Code VR is the fact that you are able to create a program, run that project, see the results, modify your project, run it again, and then see what's the result of those updates. And you're able to do that very, very quickly. The idea of having that very tight edit to execution cycle, that's critical for students when they're first learning computer science, that quick and immediate feedback. So when I see numbers like over 7 million projects ran, that shows not only how successful that is from an engagement perspective, but also from a pedagogical perspective. Students are really learning computer science with VEX Code VR, and that really makes us happy to see. The last one on there is the fact that we've had over 75 features and enhancements added in VEX Code VR. We really value the feedback that we get from you, the community, you, the users, and we're really, really excited to get that feedback and make our product, our platform better as a result of it. Not only with VEX Code VR, but even with VEX Code itself. I remember when we first released VEX Code for both IQ and V5, some of the very first feedback we get was adding a 4-motor driver train, and we did that. So we'd love to hear feedback from our users. Now, that's what really drives our product development, is that feedback. And we want to get these things into your hands as soon as possible so you can begin to use them and we can start getting your feedback. And that's going to be a really important point that I'm going to touch upon a little bit later. If you're just joining us right now and you're not that familiar with VEX Code VR, maybe the fact that we now support Python, that's what's piqued your interest. Just want to spend a few moments talking about some of the features of VEX Code VR. First of all, it's web-based, so you can go to vr.vex.com right now and start to see how we've implemented Python into VEX Code VR. You don't have to wait for me to walk you through it here in a few moments. You can get started right now yourself. So the reason why I made it web-based once again was because of access. We wanted all students and teachers to be able to access VEX Code VR. We didn't want you to have to install anything or download anything. We know a lot of you are using laptops and Chromebooks and devices on loan from the school that you cannot download anything on. So as a result, we want to make it web-based, so it works on most major browsers and almost all devices. It does use the existing VEX Code interface, so drivetrain commands you can use to program your VEX Code VR robot. You would also use drivetrain commands to program your IQ robot or your V5 robot. So this really does help you stay connected to your physical robot even if you don't have access to it right now, or even when you return to school and things do get back to normal. While you're at home, if you don't have your robot at home, this still allows you to program VEX Code VR and stay connected to your VEX robot. Virtual robots, these are pre-built robots, so you don't have to go through the process of configuring your robot. Once again, we want it to be very, very quick and easy for you to get up and running and started. But it does have some of the same physics as real robots, whether you're using sensors or your robot getting knocked course if you're doing the Castle Crasher playground. So that allows you to learn some of the basics of using a physical robot with your virtual robot. And finally, our virtual playgrounds. We've added, when I talked about the enhancements a moment ago, we've added a lot of playgrounds since this was first launched based upon feedback that you've given us. Very fun and engaging playgrounds that we have that you can utilize if you're using VEX Code VR in your classroom. Teaching with VEX Code VR, What are the benefits of that? Why teach with VEX Code VR? As I've talked about here a few times already, first of all, it's very easy to use. No downloads are necessary. You don't have to worry about keeping track of user accounts for your students. You can launch it at vr.vex.com right away, drag a block in, choose a playground, and run your robot. So within moments of opening VEX Code VR, you can get started running a project and seeing your robot run. So it's very, very easy to use. Obviously, how we've organized the commands, the fact that they're color-coded, the fact that it is a block-based programming language, all those things make it easier for you to get started. I talked about the importance of immediate feedback. No matter what you're teaching or what class you're teaching, being able to provide your students timely and targeted feedback is a research-proven way in order to be able to achieve learning gains. Moreover, if you can do that in the software itself, research has also shown it's a very effective way for you to be able to teach computer science. So students being able to, once again, modify their projects, see the result, modify it again, and incrementally try to get it to the proposed solution. Being able to do that very, very quickly and have that immediate feedback is a powerful way to learn computer science, and you can do that in VEX Code VR. And then the third one, learning made visible. Once again, this applies to all subjects, all disciplines. The idea of making learning visible so students can actually communicate what it is that they're trying to do, and the teacher can provide that effective facilitation, that effective coaching, that effective feedback. We accomplish that a number of different ways in VEX Code VR, whether it's highlighting the program execution, the step functionality that we have in it, or the dashboard that we added a few weeks ago that allows you to keep track of your sensor values, the values of your the values of your variables as they're running through the project, and also the print commands. These are all things that we've added to help make learning visible, to help put you in a successful position as a teacher, as you're facilitating your students, and also to help the students do self-directed learning on their own. Okay. New features to VEX Code VR. I'm just going to touch upon this briefly, then I'm going to jump into VEX Code VR. Obviously, being able to code in Python, being able to ease the block to text transition. We've also added a few new tutorial videos based upon feedback that we've gotten from our users. We've added some things to our knowledge base. We've added some more example projects, and we've added some more languages. So if you're some of our international friends, like in Germany, for example, and you want to be able to code with VEX Code VR, you can now use the blocks in your language. Okay? All right, so without any further ado, let me go ahead now and jump into VEX Code VR so I can begin to demonstrate for you some of the new functionality that we've built into it. Okay, so I'm going to hide my camera feed just so I don't hide anything it's important on our toolbar here. But first of all, if you haven't used it yet, you can go to vr.vex.com and follow along with me. We're open up for the first time. Everything that I'm showing you right now is live. We're kind of unveiling this as we're doing it. If I start a new project, you'll notice right here, nothing has really changed. Everything is kind of the same. But now we've added a new icon in our toolbar right in the upper right-hand corner. So if I go in and click on it right now, I'm going to open up this code viewer. Okay, so this code viewer allows me to see the Python code as I begin to build my project in blocks. So let me go ahead and drag in a drive4 command into my workspace in blocks. And when I do that, you'll see it update here in Python in text. So as I drag commands in, I'm going to drag in a turn4 command now. You can see me building that same project in Python over here on the right-hand side. Okay, so the code viewer allows me to build a project in blocks. So now I'm going to change my velocity up here. I'm going to put that at the top. Allows me to see that same project being built in Python. Now, if I delete a command, you'll see that command will go away in Python. If I delete, or now if I duplicate it and I add the commands again, you will see those commands are over there and they're built in Python right now. So what this allows me to do, once again, is as I'm building a project in blocks, it allows me to see what I'm doing right over here in this code viewer in Python. Now, I can build a project in blocks, but if I actually want to convert my project to text, I can go over here and I can click in the bottom right-hand corner, convert to text project, okay? It's going to ask me to save it. So I'm just going to go ahead and save this as, I'm just going to go ahead and save it. And now here is my project in text, in Python, okay? All the commands that you're used to seeing in blocks, here they are over here in Python. So that has not gone away with you. This is a really important point to bring up here. With Python, we're not just dropping you into a text editor and saying, okay, go ahead and learn on your own now. You're kind of on your own. Instead, a lot of the supports that we have built into the blocks interface, we've also included here in Python. So for example, I don't have to memorize the blocks. If I want to use a drivetrain command, I can click on it, I can drag it in, and I can add it to my interface right here, just like I was doing it in blocks, okay? Moreover, one of the biggest benefits that we have in blocks is the help. We've gotten a lot of great feedback on our help. You'll notice help is still here. So I can open up the help window over here on the right-hand side of blocks. Now I can click on the question mark over here of any of my any of the commands I have over here in Python, and I can get help on that particular command, okay? So a lot of the supports that we've built into blocks, we've also included that same support in here in text. So we're not just kind of dropping you in all on your own, where you have to do everything on your own and figure out everything on your own. We've built a lot of that support and scaffolding in. Now, if I want to go back to blocks, I can go back to the file menu. I can go load from my device. I'm not going to worry about saving my text project right now. And now that project that I had here, I can go ahead and I can click open, and I can open it up right now, and there is my blocks project here, okay? I can start a project in blocks as I just showed you. I can see how that project is built by opening up my code viewer over on the right-hand side, okay? Once again, I can add commands and see how those commands are added. And then I can convert that project in the lower right-hand corner of the button. I can convert that project to text. And then once it's in text, since if I did save my project in blocks, I can always go back to that same project in blocks, okay? So a lot of really cool functionality that we built in here. I'm going to open up a project that I built prior to the webinar this evening to really kind of show off some of the functionality that we built in here, the power of Python as a programming language, and also how we've eased that transition from blocks to text. So let me go ahead and go to my file menu here, and I'm going to open up a new blocks project. And, oops, I'm sorry, I'm going to load from my device, excuse me. And I'm going to open up the Disk Maze project in blocks. Oops, excuse me. I want to open that up in blocks. That was the text one I had. There we go. All right, so here is my project in VexCode VR blocks, okay? I'm going to open up my playground. So with this activity, what it is that we're trying to do is we have to use our sensor, my eye sensor, to actually go through and navigate the maze, okay? Using the colors, what I want to be able to do is use that logic. So if I see green, I do a certain action when I see green. So with the if statements, which you can see here, if I don't detect a color, I'm going to drive forward. That gets me out of my initial space here. Then when the front eye detects blue, I want to turn right. Then when I detect green, I want to turn, I'm sorry, when I detect blue, I want to turn left, excuse me. And then when I detect green, I want to go ahead and turn right. Using that logic, what that will do is I'll end up on the red spot in my playground, and that's how I kind of solve the maze. So let me go ahead and I'll run this project real quick, just using the blocks. You'll see the high in the project execution. It sees green, it's going to turn right. It sees blue, now it's going to turn left. As it sees blue on the top, it's going to turn left up there. As that's running, I'm going to go ahead and move my playground over, and I'm going to open up the code viewer that I have here in Python. So once again, that exact same project that I built in blocks, here is that exact same project in Python. Now I'm getting to the end. Now I've gone and I've solved the maze. I've ended up on the red part of the maze. Thus, I've solved it. So let me go ahead and just close the playground window. Let me talk about the project here real quick, okay? When we talk about the transition from block to text, right? I talked about this a little bit ago. The feedback we've gotten from users is, my students really have a difficult time transitioning from block-based programming to text-based programming. A lot of people think that that transition is just about syntax. So in other words, if you see the blocks over here on my left, if I have a drive forward command in blocks, if I have that exact same name in text, a drive forward command, then it makes it easy for students to transition from blocks to text. That's true, but it's insufficient. It's not the only reason why students have a difficult time transitioning from block to text. There's actually a lot more than that. This project highlights some of that. You'll notice here in the blocks project, I have if statements that are all encased inside of a forever loop. The scope of the forever loop and the scope of those individual if statements are all determined by my blocks. So I can see, for example, what's going to happen inside of this first if statement by the block itself via the colors and what's located inside of it. Okay, so now I can see if the front I detects none, for example, I'm going to drive forward and I can see the scope of that very easy visually because of the blocks. In a text-based programming language, if you're using, for example, the C programming language, scope is determined by things like brackets and curly braces. In Python, over here on the right, scope is determined by indentation. There are none of those brackets and curly braces. Instead, it's all done by indentation. So you'll see over here in the Python command, with that same if statement, the drivetrain is indented inside of it. That is what then communicates the scope. Instead of students having to learn that on their own, I as a teacher can show them that via the code viewer here. So it's a very nice way to show students things like scope when using conditional statements in loops, which is one of those things that students struggle with when they transition from blocks to text-based coding. Okay, that is something that they struggle with. So it's something here that you can visualize. Remember I talked about making learning visible? This is something that you can actually visualize with the code viewer. Something else that's interesting on here, you'll notice at the top of my code viewer, I have a variable here. My variable is equal to 0, and then outside of my loop, I have it's mentioned as a global variable is equal to my variable. If you're familiar with VEX Code VR using the blocks, you know that we always give you a variable to start with. There it is on the left-hand side of my screen, my variable. So you don't have to build one on your own to start. Instead, this starts it for you, okay? That variable is located inside of my Python program, as you can see here. But notice here, I had to, in the Python, identify the scope of the variable. It's a global variable. In VEX Code VR blocks, I don't have to worry about doing any of that. I don't have to worry about defining it as a local or a global variable. VEX Code VR blocks does all of that for me. It abstracts that out, so instead of having to worry about the scope of my variable, I can just focus on how to make a variable and how to use a variable. In Python or in any text-based language, you would have to do that on your own. It's not abstracted out. This once again gives you a great way to be able to teach that either to your children or to your students, or if a student is trying to learn it on their own. Finally, you'll notice at the bottom of my text program here, I have a wait statement. I have a wait command. In blocks on the left, there is no wait command. So why is there a wait command in my text program, but not in my blocks program? Well, as you begin text-based programming, one of the best practices or good programming practice is to include a wait statement in your loops, especially when you're programming with robots. What ends up happening is because the robot executes the program so quickly and it runs that infinite loop very, very tightly, the robot can have a difficult time determining what to do based upon the fact that it's running so fast. So what you do to prevent that from happening is you include a wait statement. This is something as you become more advanced in programming and you start using multiple threads, this becomes very important there also. But in blocks, we once again abstract that out for you. There is actually a wait statement built into the logic of the blocks. We just don't show it to you, okay? We abstract that out because we don't feel it's necessary for a beginner that's just learning basic things about sequencing and conditional statements and loops to have to learn it. It's a barrier to overcome. So we abstract that out and just let you focus on the actual logic itself. But if you're teaching Python, or if you're learning Python, this is a great way to, once again, this is a great teachable moment. You can talk about this with your children, you can talk about this with your class, whatever, but this is a great way to show, hey, why is this wait statement command in Python? Why is it not in blocks? Be able to explain that and then be able to show that, and that really helps to solidify the students' learning as they go through that. All right. So when we talk about the transition, once again, from blocks to text, it is not just about syntax. All right. In addition to that, it is about the things that blocks abstracts out in order to make it that simple environment for you to get started in. That abstraction does not happen in Python or any other text-based programming language. So it's important that you're not just able to jump the students and make them dive into that on their own, but instead you're able to scaffold that process for them. We do that here with the code viewer. We allow you to scaffold that process so you can see it. It presents those teachable moments for you. And soon, this summer, we'll begin having things like STEM labs that actually show you how this will all be done and how you can scaffold this for your students and present that teachable moment and be able to do all of that for you, okay? But a really, really nice feature to build in. Now, with all of that being said about syntax is not the only thing that's important about a block to text transition, the one thing I do want to mention here, if you notice the syntax over here in the Python language, you will notice that we did make a very friendly API. We did not make confusing commands for students or users. It's drivetrain.drive forward. It's drivetrain turn for left 90 degrees, right? So we made the blocks simple to read and follow in a quote unquote natural language. We've done the same thing here in Python in text. So we did not want the API to be a big hurdle for you to overcome. Now, with all of that being said, this API that I'm showing you right here, this is industry standard. This is real Python. So if it's the PEP8, PEP8, that is the standard style guide, for lack of a better term, for Python. So you'll notice things in here, like for example, notice how the parameters all have capital letters. Forward is capital, blue is capital. That is because of the style guide for Python, that PEP8 style guide that I mentioned a moment ago. That's why that is, okay? So you're doing real Python here, following the standards of Python. Notice how it's front underscore I over here. Once again, that is following the standards of Python. So you are, even though we've made a friendlier API, it is consistent with standard Python. Now, this is an important point to bring up. Why do students normally want to transition from blocks to text-based language? Why do teachers, for that matter, want to transition to text? It's because students want to use what real professionals are using, right? They want to be able to say, hey, is this something I'm going to be able to use if I ever want to get a job programming in using computer science or making apps or making web apps or whatever? That's oftentimes why students want to transition to text. Well, this is real Python, okay? It follows the industry standard of Python. And the other thing is, of course, we've included things in here like drivetrain commands that are specific to robotics. But if you think about it, all programming languages are like that. Java programming language, for example, if you're using a Google phone or if you have an Android device, it's using Java to program those devices or those phones. But there are things built into that, like a button press or other things, or button receive, that are built in to make it specific for a phone or for a device. Still Java, but certain libraries and things added in to make it specific to that device. We're doing the same thing here with Python. This is real Python with things like a drivetrain and turn for commands to make it specific for robotics. But this is still real Python. So if you're watching a webinar, even if you're, if you're a parent and if you're like, well, if my son or daughter uses this, are they actually learning real Python? Emphatically, yes is the answer. They are learning real Python. They are learning real text-based programming language when they are doing this, okay? One more point about that, about the friendly API. We did that for two reasons. Not only to really kind of lower the barrier of entry for students, make it easy for them to get started, but also, to be honest with you, to kind of symbolize good programming habits. If you're making a function, or if you're making a variable, you want to make those things in a way that describes what it is that they're actually doing. When I used to teach robotics, as I mentioned back when I was still in the classroom, students want to name variables X, Y, Z, or they want to use their names. So if the student's name was Zach, they want to name their variable Zach, for example. Of course, that quickly ran into troubles because they couldn't remember what it was supposed to be doing. So being able to use names of commands that could describe what is it they're actually doing, and then applying that to things like variable names and function names, that's great programming practice. You're essentially self-documenting what it is that you're trying to do in your program. You'll notice we have comments over here in the block-based program. There are also comments in the Python programming language here. So you can do that also. But this is a great example of making almost self-documenting, and that's what we want students to do when they begin programming also. All right, so that's transitioning from block to text. Let me go ahead and open up an actual Python program right now. So I'm going to go back to File. I'm going to go to Load from my device. I'm not worried about saving this project right now. And I want to go to the disk mover one in Python. Real quick, these programs that I'm showing you here right now, if you have different programs, my downloads folder, I know you couldn't see it, but when you save programs in Python, it's going to be, the extension is going to be VR Python as opposed to VR blocks. You'll be able to tell the difference when it comes time for you to open them up, okay? So this is the disk mover challenge. Let me go ahead and open up the playground for you for this real quick. So with this challenge, this is another playground that we added not that long ago, but with this challenge, what you want to be able to do is grab the blocks, grab the disks, then be able to put them back into the goal area. So let me go ahead and move this over just a little bit. The one thing I want to highlight for you here real quick is, once again, talking about the indentation of the program. You can see it on here with the Python program that I have. This is, once again, real Python. Python is one of the most popular programming languages in the world. I forgot to mention this at the beginning. I want to talk about this briefly right now. So why Python? If you're asking yourself why we chose Python, well, Python is generally recognized as one of the most popular programming languages in the world, in both an academic sense and also a vocational sense. Oftentimes in school there is tension between vocational needs and academic needs. With Python there is none. It's great. Industry is saying that we need more Python programmers, and schools, whether it's colleges with an intro to computer science course, but also high schools that are teaching CS1, they also like to begin with Python also. It's great to start as that first programming language that you're able to do, okay? So here we are. I have the language right here. The other thing I do want to mention as I jump onto that, I remember when I was in the classroom teaching and I wanted to teach my students Java, I had to program the Java, I had to download the Java virtual machine, I had to download Eclipse, which was the integrated development environment that I used. It was a big, huge headache. Notice all I had to do here was type in vr.vex.com. I can click File at the top. I can click Start a New Text Project, and I'm in Python right now, right away. So sometimes when beginning to teach computer science with text-based programming language, there's a lot of overhead that you have to do to get started. Here you have none. You can just get started right away, and it's no problem for you to be able to do that. Okay. So here's my problem. Here's my project. I got a nested for loop here. I'm gonna pick up the pucks and put them back. As I run this project, what I want to be able, I'm going to shrink my playground. I'm going to bring up the monitor window over here, the monitor tab. This is something, once again, that we added not that long ago. And as I go and I play this project now, it's going to take a second to load. The project's going to begin running, and you're going to see the sensors being updated over here in the monitor tab on the right. This all goes to what I was talking about making learning visible. The variables being updated, and you can see the print statement down here also being updated as we are going through all of this. Okay. The reason why I'm able to do this is at the top of the program here on lines 6 and 7, I have these two monitor commands that we're using. This is another example of something that we added to Python in order for you to be able to see this and see this in your browser as this is running. I want to emphasize to you that this is really cutting edge technology that we are using. To get technical for a moment, we are using something called Pyodide to run this in your browser. Okay, it's a web-based Python engine that we're using so that you can use this in your browser. You don't have to download anything, you don't have to install anything. The project is being processed on your browser itself, not in the cloud or anywhere else like that. So as a result of it being cutting edge, we're really going to rely upon your feedback, okay, in order to make this better. So just like we've added a bunch of things based upon your feedback, because it's new, because it's cutting edge, of course there's going to be a few bugs and things of that nature, but we wanted to get this out to you because at the end of the day, you, our users, you're the one that's going to make this project better. So of course, we could have kept this for another month. We could have kept testing it and things of that nature, but we wanted to be agile. We wanted to get this out into your hands so that you could begin using it, give us your feedback, and please use the feedback button in the upper right-hand corner of the screen. I love getting emails, don't get me wrong. I love hearing feedback people on Twitter, but with that there, that goes directly to our development team. If you did encounter a bug, we're able to look at your project file. We know what device you're using. So that makes it really easy for us to be able to push out updates, to fix bugs, but also hear what problems that you're having and use that to be able to make the software better, to quote unquote make it smarter so you don't run into those same issues. Okay? So this is really cutting edge stuff that we're using in order for you to be able to use this right now and to keep that accessibility. We want everyone to be able to use this. Now, obviously, when you get into text-based programming, you run into the issue of compiler errors, right? So in blocks, you really don't have compiler errors. Blocks essentially doesn't let you run into that problem. You can, however, run into that problem once you start doing text-based programming. So let me go back down here. I'm going to go to line 47. All right, see if the disk counter is not equal to 9, okay? And I'm going to go ahead and I'm going to delete that colon there, okay? I'm going to clear what's in my print window over here, and now I'm going to run the project again, okay? So I hit play, and now it tells me I have a project runtime error. Please check the print console for more details. So now if I go over to the print console, it says line 47, if disk counter is not equal to 9 and I have invalid syntax. Okay, so now it's telling me on the line where it is that I'm having a problem. This is actually another example of where students have a problem transitioning from blocks to text. Not the error in of itself, but the fact that in blocks they never have to read error logs. They don't have to read error messages, right? So if you have a long, confusing error message, that could be a problem for students. We want to make something very short and very concise, and you can see that we've done that there. Now I'll go ahead, I can see, okay, line 47, that's where my problem is. I'm going to go ahead, and now I'm going to add the colon, okay. I'm going to go ahead and clear that. Now I'm going to go ahead, well, let me clear the playground. Now I'm going to go ahead and I'm going to run it again, and now I can go ahead and run it, and I'm not going to get that same error, okay. So a lot of really cool things that you can do and then you can show there. Just a couple other things here real quick. I do want to mention and talk about First of all, one of the cool things that we've also built into this, because this is all in one software application, students can learn new things in blocks and then transition over to text. So what I mean by that is a student doesn't have to go into text and always stay in text, right? So let's say that I've been programming in blocks. I want to start programming in Python and text. I can do that. But now, and you can make this decision as a teacher also, but now I want to learn a new concept like variables or lists, or I want to learn modularity. So I'm going to start using things like MyBlocks, right? I can do that in blocks in the more comfortable programming environment. And then when I feel comfortable about it, I can then go ahead and program those things in text. It could be scaffolded for me by using the code viewer, but once I'm kind of done with the code viewer, I can go ahead and just start straight from a text project. One other cool function I want to show for you here real quick is you might have used our share functionality previously with blocks. Basically what that does is that takes a PDF of your code so you can see the blocks that your students are running or that you're running yourself. Now if I hit the share button up here in the upper right hand corner of my screen, I click on that, it's going to now download. I'm going to get a warning here in the lower left hand corner saying do I want to keep this? Yes, I do want to keep it. Now it's going to download it for me. You can see it's called diskmover.py. That's the standard Python extension. Okay, so remember I said a minute ago it would be .vr Python if you were in our application. Well, with the share, it downloads it as a .py extension, and now it just projects it. It just puts it in my text editor. So if you're a teacher that's been teaching computer science for a while and you have a particular text editor that you like and you want to be able to review your students' code in that text editor, you can use our share functionality to be able to do that right now. I can go ahead, unlike the PDF that is static that I get in blocks, I can go ahead and I can delete things up here. I can add things, whatever. I can do all of that in my text file that I have here. One more thing that I want to show you that I just want to kind of review some of our updates and I'll get to your questions is our autocomplete. So we also, in addition to being able to drag the blocks in and be able to use them, we also have autocomplete built into VexCode VR. So let's say, let me find a good one to use here. Here we go, drivetrain command, a very simple one to get started with. So here on line 17, I have drivetrain .drive forward. Okay, so if I go and I delete this, okay, and I'm going to show off the autocomplete. I want to add it in, so I can go drive, and that brings up my drivetrain there. Okay, dot. Now I just want to use the drive direction command, so I can click on that. Then I can click on forward. All I have to add now is my closing parentheses there, and I have it. Okay, so the autocomplete is a really nice bit of functionality that we've added in there for you also. So once again, we're not just dropping you in and making you get started all on your own. Now, if I have no idea what to get started with, if I can't remember what I want to use, what I can do then is I can hit Control Space and it brings up all the commands that I can get started. Like, oh, I wanted a drivetrain command. I can click on that and I can go and I can get started there. Okay, so before I typed in the D to get the drivetrain started, and if I can't remember what to do, I can hit Control Space and I can bring it up that way. Okay, all right, a couple things real quick. I mentioned the beginning slide tutorial videos. Let me go back to blocks, a new blocks project. We added a bunch of new tutorial videos based upon your feedback. Some teachers were saying they're having a hard time getting projects emailed from their students. That was because students might not be able to, couldn't remember where their project was saved or how to load their project. So now we've had it specific to different devices. Save your project on an iPad, on a Chromebook, on a Mac, on a Windows machine, and then also load your project on a, I'll just click on the Chromebook one here, load your project on a Chromebook, Mac, whatever those particular things are. We have all those tutorial videos right now. So if you have students have a difficult time I've saved my project, but I can't find it in order to email it to you or whatever. We have these tutorial videos here in order to be able to show that to you. Okay? So a lot of really nice things. But I did mention languages also. So if I click on the upper left-hand corner, the icon, we've added some new languages. So we've added German, Lithuanian, Turkey we've added, a couple other ones that are up there that you can now, once again, for our international friends, you have an opportunity to use those different ones there. Okay? I'm going to go ahead and turn my camera feed back on and walk you through a couple other different things here. A lot of the things that I just showed you are supported in our knowledge base. So if I go to VR now, you'll notice we have two new subcategories here, one for VR blocks and the other one for VR Python. So all of the VR blocks articles are located for you right here, and we've added some new ones also for Python. So how to access help. We do have one that I do want to point out to you for technical implementation details. So if you, I mentioned Pyodide previously, there it is right there. If you have questions, if you're an experienced Python user and you have questions about what is supported, what's not supported, those types of things, I would point you to this document right here. This is a more technical document that talks about the implementation details of Python. If you're looking for something much simpler, like how to create a project in VEX Code VR Python, we do have those articles for you also. Stay tuned to this. We're going to have a lot more of these upcoming in the near future to support everything that it is that you're trying to do with your projects in Python. Okay, so stay tuned to the knowledge base. We'll have a lot more updates for that upcoming. All right, so let me go back to my presentation mode here. All right. So I talked about transitioning from blocks to text, all the advantages that are located in VEX Code VR there. Coming soon. So new updates coming soon that we have coming out. So this is what a lot of people have been asking about. So I want to make sure that I get to this. I think there's been a lot of questions about this in the chat already. We will have Python for V5 in the same manner that I just showed it to you with the code viewer functionality in June. We will also have C++ in June for V5. We're going to support C++ with IQ also coming a little bit later in June. So if a lot of people are asking, when will I be able to use Python with my V5 robot, that's going to be coming in early June. Additionally, C++, and then IQ C++ is also going to be coming later on in June. Stay tuned also, we are going to have one on we're going to be upcoming here soon with a VEX Code VR certification. So our educator certification program has been very successful for IQ and V5. We have over 1,000 educators certified in IQ and V5 right now, so we're very, very proud of that. You may have noticed that we've released new certifications for referees for the new games. That's going to be coming also. We're really excited about our certification program. There's going to be one for VEX Code VR coming soon, so pay attention to that, and keep tuned into VEX, our social media, and also our VEX newsletter just to get more information about that. Okay. So what did you learn today? New features of VEX Code VR, talked about that. Being able to program with Python with VEX Code VR. Transitioning from block to text, spent a lot of time talking about that. The advantages of using VEX Code VR to teach computer science, once again, talking about how to be able to do that with with our code viewer, being able to transition from block to text. And I just talked about key updates to VEX Code and VEX Code VR. One thing I did forget to mention, if I go back to the previous slide for one moment, our VEX Code VR certification, that is going to include both teachers and students. So educators that want to learn how to use VEX Code VR in their classrooms and how to program with VEX Code VR, like an introduction to computer science, that's going to be available. And then not that long afterwards, we're going to have a certification available also for students that want to learn VEX Code VR on their own or want to learn it in their classroom, wherever. You'll be able to do that also. Okay. What's next with Vex? So two websites I want to share with you here real quick. One is new. The other one is one that we've had before. So vexrobotics.com/coming soon, and also our code features. So let me go ahead and get out of the PowerPoint real quick again, and then show you these two websites. This is the new one coming soon. So this literally just went live, I think today, as a matter of fact. So let me kind of scroll. This is more hardware related. So things like the pin tool is available now. You can click here to purchase one here right now. A lot of people have been asking about the Vex IQ field upgrade coming soon. Information on that. The inertial sensors available now. Optical sensors, you can see here, available in Q3 of 2020, the distance sensor, Q3. So information about when sensors are available, information about the Vex AI competition is also located on here, the GPS, the camera, VexLink, information about VexGo 123. All of that is located on here. So you can see the URL up here, vexrobotics.com/coming soon. You can check that out, bookmark that site. You can see all kind of things that we have going on with our different hardware selections right there. The other one that we have, these code features, this is our development roadmap. So if people are wondering when something is coming out, when are you gonna have Python for V5 and things of that nature, you can go to here and see all the information that we have on here to be able to answer those questions for you. So this is, if you go to our code.vex.com, I'm going to show you how to get here. If you go to code.vex.com and then you click over here on the right hand side, features, that's where you can get basically our roadmap for our software delivery, organized by different devices, language compatibility, getting started, languages, things of that nature are all located on there. Okay, so let me go back to the PowerPoint. All right, and let me just fix this real quick. Okay. Please continue to share with us your VexCode VR projects. We've got a lot of great feedback on Twitter. Please continue to do that. The projects your students are using, the projects that you're doing, you're learning. If you've created a tutorial for VexCode VR and posted it on YouTube, share that. Tag me in it. Tag VexCode VR. Tag Vex Robotics. We love to see what you, our community, are doing with VexCode VR. So please keep it up. We love to see this stuff. Please share it with us so we can comment on it, we can retweet it, being able to do all of that. And now I think we're ready for our Q&A questions. What is a good age range for Python? Great question. Back in the day, when I was in the classroom, I used to teach Robot C text to my 5th graders. That was because Robot C Graphical was not out yet. So really, to be honest with you, a lot of it, there's nothing from a cognitive perspective that would tell you, here's the cutoff age to begin text-based programming. A lot of it depends upon a student's ability to type, a student's ability to manipulate things like a mouse and doing things of that nature. That's why you don't see very young students obviously doing text-based programming. As students become more comfortable with the keyboard, with the mouse, and doing those types of things, they can begin doing text-based programming. Obviously, the hurdle to get them started doing text is a lot more difficult than it is with blocks for all the reasons I mentioned a few moments ago. So to me, it's not really a question of when should I begin, what age should I begin students with text-based programming, but when do I feel like it's necessary based upon their individual readiness to get them to begin doing text-based programming. This is analogous to anything that you start doing in education. You know, when do I progress students in their reading to small young adult fiction books? When do I bring them out of like small storybooks into larger books? Those are all decisions you make as parents and educators based upon the individual needs of your student or your child. The great news about VexCode VR is you don't have to make one decision for everyone. Because everything is located in the software, you can have some students working in text while you can have other students working in blocks. So based upon their readiness levels, based upon their progression, we know all students learn at their own rate. So instead of trying to force them all into text at one particular age, see upon the comfort level of your students, and students can actually kind of decide it on their own. As I mentioned, if they want to begin learning a new concept, they can learn that in blocks and then start applying it in text. They can essentially self-scaffold on their own. So there's no, the research tells us there's no specific cutoff date. It really depends upon the individual thing about your individual readiness of your students. But instead, what I really want to emphasize is the fact that VEX Code VR allows you to make that decision on your own. Okay. Other questions? Looking through here. So teaching text-based programming first, is that a good idea, or should I just get started with blocks? This is a question that I get asked a lot. This kind of goes back to what I talked before about the tension between kind of academic needs and vocational needs. You see that tension be illustrated when people ask things like, should students begin programming in blocks because real programmers don't use blocks? That's actually technically not true. If you start, some large industrial robots are actually begun to be programmed by something like a block-based interface because it's easier for the mechanics on site and the people on site working with those robots to be able to use a block-based programming language. So that statement in of itself right now is not true, that all real programmers use block-based programming. Secondarily, the research is very clear in the fact that students can learn introductory programming concepts and practices as a result of using a block-based programming language. At the end of the day, computer science is not about a language. Whether it's block-based, text-based, whether it's Python, Java, JavaScript, whatever, computer science is about concepts. Just like learning about reading comprehension is about concepts. It's about vocabulary and context clues and things of that nature, not a particular text. Just like computer science is not about a particular language. As teachers and educators in schools, we should be focused on teaching students things like algorithmic thinking, sequencing, building the basic blocks of an algorithm using conditionals and loops, then get into things like abstraction and modularity like I spoke about a moment ago. Those are the big ideas about computer science, and that's what we should be focused on. Research is very, very, very clear in the fact that a great way to get started with that is via blocks. Research is also very clear that then transitioning students from blocks to text can be a hurdle. The hurdle is not just about syntax, it's additionally about the things that the blocks abstract out, which are then introduced via syntax. Via the code viewer that I showed you earlier this evening, we feel like we've made a lot of progress easing that transition and making it easier for you as parents, teachers, or students to be able to overcome that hurdle of going from block to text-based programming and be able to continue doing that. And we're not done. Just like we've added over 75 features to VEX Code VR since its initial release, we're going to get your feedback. We're going to continue to do our own research and read the research and determine what are other ways that we can ease the transition from blocks to text-based programming for our users so we can then prepare, as we like to say, the innovators and the problem solvers of tomorrow. Okay, we are getting close to the end, so let me just do a couple slides here, our typical wrap-up slides. Resources, right? There'll be a blog post going out tomorrow. A lot of the stuff that I just talked about Python, why it's a great programming language to start with. Some of the things that I mentioned here about transitioning from block to text, that'll all be in the blog post tomorrow. So check that out, please. There'll be an email blast going out reminding folks about this webinar. If you did not get a chance to see it, you can go to YouTube and watch the recording of it. Please check out our STEM labs. We have some exciting news about our STEM labs upcoming in a few weeks that I can't wait to share with you, so stay tuned for that. And our educator certification program, I just talked about the fact that upcoming we are going to have an educator cert for VEX Code VR. We're also going to have a student certification for VEX Code VR, so we're really happy about that, so stay tuned for that. Thank you very, very much for joining us this evening and learning about our latest update to VEX Code VR for Python. If you have any questions, please feel free to email me. If you have ideas for future webinars or whatever, tag me on Twitter. Also, If you have feedback about the software itself, use the feedback button in the software. But otherwise, please feel free to reach out to me. Thank you very, very much for joining me this evening. It was great chatting with you, great questions, and I can't wait to talk to you at our next webinar. Thank you.